Have you ever wondered how calculators find square roots, factorials, trigonometric values, or logarithms? Do we have to write all those formulas ourselves in Python? The answer is no. Python already provides a powerful module called math that does all of this for us. In today's video, we'll first learn the important functions of the math module and then build a fully functional calculator using them. So let's get started. Hello everyone, welcome back to the channel. In our previous videos, we learned variables, input and output, operators, conditional statements, loops, and the random module. Now it's the time to learn another very useful built-in module called math. Instead of creating formulas ourselves, we can simply use the functions already provided by Python. By the end of this video, you'll also create a practical calculator project using these functions. Let's begin. The first step is importing the math module. Think of a module as a toolbox. Whenever we need mathematical functions, we simply import the toolbox and use its functions. Without importing it, Python will not recognize functions like square root or factorial. sqrt means square root. It accepts one number and returns its square root. 25 becomes 5. Another example, 144. Let's run the code. So we have got the square root of 144, which is 12. Next function is power. First argument is the base and another is exponent. So this is equal to 5 raised to the power 3, which is 125. Compare it with this. Both give the same answer, but math.power always returns a float. Next function is ceiling. Ceil means smallest integer greater than or equal to the given number. 5.2 becomes 6. 9.01 becomes 10. It always rounds upward. Floor means largest integer smaller than or equal to the given number. 5.9 becomes 5. 8.99 becomes 8. It always rounds downwards. Our next function is factorial. Factorial means multiplying all positive integers till that number. In mathematics, we write it as 5 factorial. So the result is 120. GCD means greatest common divisor. It returns the largest number that divides both numbers completely. Let's check the output. The GCD of 24 and 36 is 12. LCM means least common multiple. It returns the smallest number that both numbers divide exactly. Let's check the LCM of 12 and 18. It's 36. Instead of remembering 3.14159265358 and so on, Python stores it for us, useful while calculating area and circumference of circles. Next is Euler number. Euler's number is approximately 2.71828, which is used in higher mathematics and logarithms. Next is logarithm. This returns the natural logarithm. This is mostly used in higher mathematics and data science. These functions expect the angle in radians, not degrees. Since we usually think in degrees, we first convert degrees to radians using math.radians. Let's check the output. Now let's look at another useful function called round. Unlike square root or factorial, this function doesn't belong to the math module. It is a built-in Python function, so we simply write round. The round function rounds a number to the nearest whole number by default. So 5.67 becomes 6. 5.23 becomes 5. We can also specify how many decimal places we want. So here this returns 3.14 because we asked Python to keep 2 digits after the decimal point. This function is very useful when we don't want long decimal values in our output. Now let's understand how this calculator works. We first imported the math module because we'll use many mathematical functions like square root, factorial, GCD, and sine, cos, tan. Next, we use a while loop. This keeps the calculator running continuously so the user can perform multiple calculations without restarting the program. Inside the loop, we displayed a menu of all available operations. Each operation has a unique number. The user enters the corresponding number to choose an operation. We store that number in the variable choice. After that, we use an if else ladder. Each condition checks which option the user selected. If the user enters 1, addition block executes. We ask for two numbers and display their sum. Similarly, option 2 performs subtraction. Option 3 performs multiplication. And option 4 performs division. In the division section, notice that before dividing, we check whether the second number is 0. If it is 0, we display an error message because division by 0 is not allowed. Otherwise, we perform the division. Option 5 calculates the square root using math.square root. Option 6 calculates powers using math.power. Option 7 finds the factorial. Option 8 and 9 calculate the GCD and LCM of two numbers. Option 10 and 11 demonstrate the difference between ceil and floor. Ceil always rounds upward, while floor always rounds downward. Option 12 displays the value of pi stored in math.pi. Option 13 displays Euler's number using math.e. Option 14 calculates the natural logarithm using math.log. Options 15, 16, and 17 calculate the sine, cosine, and tangent values. Before calling these functions, we convert the angle from degrees to radians using math.radians, because these trigonometric functions expect the input in radians. Finally, if the user enters 18, we display a thank you message and use the break statement to exit the while loop. If the user enters any other number, the else block runs and displays invalid choice. This project combines everything we have learned so far: input and output, variables, conditional statements, loops, importing modules, and using functions from the math module to build a practical application. If you found this project useful, don't forget to like the video and share it with your friends. If you are new to the channel, subscribe, because in the next project, we'll build another practical Python application. Thanks for watching, and I'll see you in the next video.